Hello, good day everyone. What we are asked to calculate in this question is the length of the red line, that is this line AB. Let's assume its length to be x. We have the length of this line segment to be 4 meters and this is 6 meters in length. We can see this side CE and this side BE are congruent. We have this angle to be a right angle. So how can we solve this? How can we calculate the length of this red line? Well, it is very simple. I'll start from these congruent sides. Since they are congruent, that means if I assume the length of this side to be y, this must also be y. Now let's look at this triangle CDE. Because of this right angle, it is a right angle triangle. We have the length of this side to be 6 meters and this is y. If we assume the length of this side to be z, we can use the Pythagorean theorem, which states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. The hypotenuse is the side facing the right angle. So by Pythagoras, the square of this y must be equal to the sum of the squares of this 6 meters and this z. So y squared equal to 6 squared plus z squared. 6 squared is 6 times 6, which is 36. Now subtract 36 from both sides. Here 36 minus 36 is 0. So y squared minus 36 equal to z squared. Take the square root of both sides. Here square root of z squared is z. So square root of y squared minus 36 equal to z. That is z equal to square root of y squared minus 36. We keep it aside. Now come here, draw a line that will connect this point A and this E. Let's assume its length to be V. Now look at this triangle ADE. It is also a right angle triangle. We have this side to be V. This side has its length to be the sum of this 4 meters and this 6 meters, which is 10 meters. And this is Z. So by Pythagoras theorem, the square of this V must be equal to the sum of the squares of this 10 meters and this Z. So V squared equal to 10 squared plus z squared. 10 squared is 10 times 10, which is 100. Z squared, from here, we have its value to be square root of y squared minus 36. Substitute it here. Square root of y squared minus 36 all squared is y squared minus 36. This 100 minus this 36 is 64. So v squared equal to 64 plus y squared. Keep it aside. Now look at this quadrilateral ABED. All 4 of its vertices are lying on the circumference of the circle. That makes it a cyclic quadrilateral. One of the properties of a cyclic quadrilateral is that opposite angles are supplementary. That is, this angle and this angle must sum up to 180 degrees. So since this is 90 degrees, this must be 180 degrees minus 90 degrees, which is 90 degrees. That is, it is also a right angle. Now look at this triangle ABE. It is also a right angle triangle. If we use the Pythagorean theorem, this is the hypotenuse. So the square of its length must be equal to the sum of the squares of this x and this y. So v squared equal to x squared plus y squared. Now come to this equation. V squared equal to 64 plus y squared. Replace v squared with x squared plus y squared. So x squared plus y squared equal to 64 plus y squared. This y squared will eliminate this y squared. So x squared equal to 64. from which x equal to square root of 64, which is 8. So x equal to 8. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.